I'm Dr. Lawrence W. Moore, and this is Lesson 3 of Learning Synthesis with Pure Data. In this lesson, we're going to be working with wave shaping. Wave shaping is basically when you design your own wave shapes, and you can do it in any number of ways. But we're going to focus on how you can use Pure Data to create the basic waveforms. In addition to sine, which we covered already, we'll be seeing how to make, through wave shaping, exact square waves, as well as other pulse waves, triangle waves, and sawtooth waves. These are the basic waveforms in synthesis, and you need to be able to use them. So, without any further ado, Crafty and I are going to teach you a little bit about wave shaping in Pure Data. Okay, so we are here at my website because I just wanted to point out, as a reminder in case I have any new viewers, that if you go to lwmmusic.com and the learning page and scroll down, you'll see for each lesson there is a download here, a zip file for each lesson containing the patches from each lesson. I have lessons 1 and 2 up. This is lesson 3, so it is not up yet because I'm recording it now, and I'll be making the supporting patches to go with it along with you. If you like to make them on your own with me, great. If you want to download them, you can do that too. So let's get on with the lesson here. I have PD open and a blank folder where I'm going to put the patches from this lesson. And so I'm going to go to the File menu, make a new patch. And I'm going to extend it out. And just so it's easier to view, I'm going to put on my magnifier and zoom in. Okay, don't need to see the whole area. Let me maximize it, in fact. There we go. Okay, so we're going to make the 4 basic wave shapes: sine, triangle, square, which is part of the pulse family, and sawtooth, and we're going to do it using wave shaping as a technique. Now, I know we've done sine already, but there's something about the sine that I'd like to show you. And what we're going to do that, I'm going to make these all with arrays so we can visualize them. So as we've done before in lesson 1 and 2, well, at least in lesson 1, we're going to make an array. I'll call it sine, and it's going to be 100. 100 is going to be its size, which means 100 pixels going across. Well, actually not pixels, but samples going across. And I'm going to change it to Bezier curve here. It makes it look a little nicer, connects things up. Press OK, and here we go. Here's our sine wave array, and we'll put a sine wave in there. But I'm going to do something a little bit different. I'm going to make our oscillator object, OSC tilde, and I'm going to leave it without an initial frequency. We'll pop frequency in. But what I'm going to do here to control frequency is make a horizontal slider. Control-Shift-H or Command-Shift-H for Mac gives you a horizontal slider, and by default sliders have a range of 0 to 127 for use with MIDI, since many values in MIDI are in a range of 0 to 127. Next, we're going to make an object called M2F. MTOF. Now what this is a converter that converts MIDI note numbers, which are also in a range of 0 to 127 with our slider, into frequency numbers. Now if we want to see these numbers, actually we can. I didn't put in the number boxes. They're not necessary, but I'll put them in so you can just see the conversion in case you're interested. And there we go. That was Control 3 is the shortcut for number boxes, or Command 3 in Mac. Oh, when you touch an object, I'm going to make another one right away. Whether it's a number box or whatever, it a lot of times just hooks it up to whatever you touched. Alrighty, so we want it up here, actually, going into the left inlet. I'm going to move this down because we're going to use the right inlet as well. But what I'm going to do is make a message box that's Control 2 or Command 2 in Mac and put a 0 in it. This is going to make its phase 0. That's usually how it starts anyway, but I'm just making sure. Alright. Actually, I'm going to move this over here. Move this over and move this over here because I'm going to make a few things up here. I'm going to make a bang, which is Command-Shift-B in Mac or Control-Shift-B in PC. Makes this little object that in run mode you can hit, and it sends out a bang. And the bang is going to execute a few things in order. First thing I'm going to have it execute is to send this message. This message gets sent to PD itself. It begins with a semicolon on a line by itself, so you hit enter. Then PD DSP 0. Now this is a message that the semicolon on its first line by itself means send this message to PD wirelessly without a patch cable hooking it up to anything. And then PD DSP 0 means turn DSP off. Now right now it's off already, but I just want every time you hit this bang for that to happen. Okay. And then I'm going to put a delay object in. Delay 10 milliseconds. What this does is it receives a bang, and then sends one out again after the amount of time that you put in. And the amount of time is in milliseconds. 10 milliseconds is very fast, but it should be good enough for what I'm doing. And now what I'm going to do is have this delay hit, excuse me, a couple things. It's going to hit this PD DSP 1, which is the opposite signal of this one. This turns DSP off or sound off. This will turn it on, or turn signal flow on. And then it's going to bang our 0 there for phase. Make sure our oscillator starts off at 0 phase, meaning the beginning of the waveform. And then we're going to bang the number 69 into our slider. The reason why I'm using that number is that is A440, which lines up pretty well in the array so that we can see the wave shape. Okay, there we go. Now, oh, there's one other thing I'm going to hook up here, and you're going to see. It's going to be our old friend tab right. An object tab right tilde, and I'm going to put sine after that, meaning our sine table. So this array I just made that's called sine is going to be written to at this bang with this bang as well. But we need to also hook the output of oscillator OSC tilde to tab right. Now I'm going to show you what this does. Make sure I hooked everything up correctly. I'm going to go into run mode, Control E in PC, Command E in Mac. Gives you this arrow, so now you can click the bang. And there you go. What we see here is basically an inverse cosine wave. The OSC object actually makes these. Now, when you have a bang going repeatedly to tab right, as we've done in previous lessons, you see the wave continuing to flow. Basically, signals flowing, and it's taking periodic pictures of it, like 10 times a second is what we did before. And so you see the waveform oscillating. Right now we just took one snapshot of it. And what we did is we told it turn DSP off. And then all at once, it's telling it to put a frequency in of 69, well, a note of 69, which gets converted to 440, as you see here, by M2F. So the oscillator's oscillating at 440 hertz. Its phase at that moment that it begins is 0, meaning right at the beginning of its wave shape. And then DSP also goes on at the same time. I was careful to put these in order here. PD operates right to left, top to bottom, and just to be careful, a lot of times things that you want to make sure happen first, even though it may only be just the smallest of instance earlier, I want to make sure DSP was on before these went through. And of course, it also, this patch cable, since it's vertical, looks like it's hooked up to the message box, but it isn't. There we go. It also took a snapshot of it. Now actually, it still worked even though this was to the, I guess the bang got sent through all at once. But just to be safe, it should be like that. So what I did is I took a picture of this, or a snapshot of the waveform as it begins. And so really our oscillator tilde object makes inverse cosine waves. And if we hit this again, see it's the same picture. Now if we change our phase here, you'll see that for phase, that's when the where in the cycle does it begin. Here's a complete cosine cycle, and basically if we begin over here, it'll look like a sine wave. So this is actually about 3/4 of the way through, or actually it is 3/4 of the way through. In PD, the 0 to 360 degrees of a cycle is expressed in a range of 0 to 1. So if we want to start 3/4 of the way through, we put in 0.75, which would be 270 degrees. If I hit this now, there we go. Now we see a sine wave. So basically OSC tilde, yeah, we say it makes sine waves. It kind of does, but technically it starts off as an inverse cosine. So that's the shape that it really is, but it doesn't sound any different. It'll still sound like a sine tone. And actually, to hear things, I'm going to do this to be careful. Crafty warned me not to buzz your ears. So I'm going to make a star tilde object. That's our amplifier slash attenuator. I'm going to say 0.2. That means it'll be at 0.2 loudness. And I'll have it go through this before it goes into the DAC. Because basically, since our sequence of events here does leave DSP on, this is running, this is currently oscillating. But since we're not sending bangs to tab right in sequence, we're not seeing updates. We're not seeing like an animation of the waveform. We don't see it flow. But it really is still going. Let's hook it up. There we go. Now if I hit DSP 0 up here, that turns it off. So we don't have to hear it. But basically, it'll sound the same. The point at which it would sound different is when this is juxtaposed. Well, now it is a sine wave because I changed its phase. But if you have two of these juxtaposed to one another with different phases, that's when you'll hear some differences. That's when you'll hear one and the other basically either adding to one another or subtracting from one another. Like if one's going up while the other one's going down, you know, you'll hear the sum or the difference of the two. And so, let's say one's going down and the other one is also going down, but maybe not in the same time, you'll hear, or you'll see basically a reduction over here in the wave table. I think I'm going to do more on phase later, but maybe right now it'd be nice to put in a second one to see what happens and to hear what happens. I'm going to do this. I'm going to move things over a little bit. Let's make a second one. To keep things on screen, I'm going to make the table sizes smaller. So I'm going to right click on the top and go to Properties. I need to give them different names, or else PD will have an error saying that something is multiply defined, meaning you have two things of the same name, and you can't have that and have things work effectively. So I'm going to make them Sine 1 and Sine 2. Well, that's right, I was going to change their size too. The one properties window that comes up, you see here, has size. And the size and height is what I'm going to change. I'm going to make it 100. Yeah, the width could stay at 200. But this one I'm also going to make it 100 pixels tall. Now when you change the size here, it's changing the size in pixels for the display, but it still technically has the same number of samples inside horizontally. I didn't change those, but it still also has the same vertical size in amplitude. It's just you don't see it because you made it smaller. So anyway, let's go on here. Now I want to make one more. I'm going to select and duplicate. I'm hitting Control D, Command D, and Mac to duplicate. But of course you want to rename them. And this is going to be the one that's going to have an overall display. I'm going to call this Result. Okay, so now what we need is another oscillator object. Hit Command 1, and it put it down here. Yep, let's move this up here. I'm going to make this another OSC tilde. And this is going to receive the same pitch information, same frequency. It will receive a different phase though. So let me move this 69 over. It worked over there before, so it'll work again. Let's put another message in. Okay. And this message, let's see, that's 0.75. Let's make this one 0. Put it there. Now, this one's going to write to Sine 1. I need to change the name here in tab right. Alright. Oh, there's no space between Sine and 1. You can't have space in array names. Oh, I did put a space in, but it corrects it and puts an underscore. So let me put the underscore in. Thank you, PD, for correcting that oversight. Can't have spaces in the names. So Sine underscore 1 and Sine underscore 2. Okay, and the second sine will be the one on the right here. Now this one will also receive the bang from the delay. Okie dokie. Now the result here, what I'm going to have to do is the following. I'm going to leave this attenuator here for when we want to hear things. That way it won't be too loud. But for our visual result table, we want to see these two waveforms added together. But if we add these together, they'll start popping out of the table because it's literally adding together in some spots and some spots subtracting from each other. But I don't want it to appear out of the table. I like it to be in the table, so I'm going to multiply both of these outputs. I made a plus. I'm thinking ahead of myself. So let's have a star tilde. Oh, did something wrong there. Star tilde 0.5. I'm going to duplicate this and make two of them. So that way both of these are cut in half. So that way when they're added together, they'll fit within the tables. Or they'll fit within the result table there at the bottom. because now I'm going to add them together. That's a plus tilde right here. And hook them up. I'm not going to hook it up to the output yet. We'll hear that later. Right now I just want to see the result. Let's do tab right, tilde, result. And that gets hooked up to the delay as well. So all these things happen at once. And I need to feed this adder into this last table as well. So now let's see if this works. Okay, so now what we got is basically one oscillator is oscillating beginning as a sine wave. The other one's beginning as an inverse cosine. Basically, they're out of phase with one another. And where they're out of phase, they add and subtract from each other, and you see a result like this, where now it looks kind of like a kind of smoothed out sine wave in a way. Now, let's try this. Let's change some phase here. If I put them in the same phase, let's say 0.75, we'll just see a nice tall sine wave there, full size. Because now this sine wave, which is cut in half, this sine wave, which is cut in half, get added together so they complete a whole one again, full size. And let's see here. Let's put this one at 0.5 and put this one at 0. And go. There we go. This one is the inverse cosine wave. This one's a cosine wave. And you see where this one is subtracting, this one's adding in perfect precision with one another. So the result is complete phase cancellation. And so that's what you get as a result for doing that. Now, if we were to hear that, we wouldn't hear much. So I'm going to hook this up now. Yeah. Hit it again. So you see, yeah, we're not hearing anything. Sound is on. But if we shift one over, let's make this one 0.75 again. Now we do hear something as a result. Let's do this, 0.25. Okay, we don't hear a big difference there. But what I'm going to do, turn off sound temporarily here. I'm going to set this one up, the result, with a metro object, which will repeatedly bang it every 100 milliseconds. And we've made these before in lesson 1 and 2. And we're going to put a toggle on it. That'll make our result table continue to flow. Now, what I'm going to do is I'm not going to hook it up to this. I'll just click on the toggle now just so it will flow. And alrighty, I turned off DSP so it's static. There's nothing flowing right now, so it can't put new data into the table. But I'm going to hit this. So we see that kind of a sine wave. Now let me turn it off. What I'm going to do is change phase now. And I'm going to change it periodically, which means actually I'm going to move this one up, put the same stuff into sine 2. Or actually, you know what? How about we have them all be mobile? Well, no. Let's just see. Yeah, let's leave it as it is. Never mind. I'm going to make a slider, horizontal slider. Control Shift H, go to its properties. I need to change its range to 0 to 1, because that's the range of phase in PD. I'm also going to go up here to properties and make it smaller. Since it's 0 to 1, I can make its width 101. and it fits better. And this will control the phase of the right oscillator once again, but now I'll be able to change it. And what I'm going to do, actually, before I hook this up to that oscillator, I'm going to make a trigger float bang, TFB. Stands for trigger float bang. And what it'll do is out its left outlet here, this is where the float gets sent. Remember, float is just means a number. It can have a decimal point in it and all sorts of digits before and after it. It just basically means number. And then I'm going to have it bang here. So every time I update the phase of the Sine 2 oscillator, you're going to see this table update. It'll stay static except for when I change this, but it'll continually update so you can see what the new phase is as you change it. Now let's put this at 0. Turn it on. The cosines line up. And now you see at different positions it could sound quieter, like there it's subtracting more than adding. There it's still subtracting more, but there we go. Now it's adding a lot. And here's subtracting a little bit more. And you can see, like if you were to add these two tables together, you can see where, where this one has a crest, this one's troughing it out, pretty much smoothing it out. And where this one's cresting, there's also troughs here. They're not enough to eliminate the crests, but they're enough to reduce them. So that way you see kind of like a reduced amplitude waveform. So let me turn it off. But basically, what this shows you is that phase, okay, I just hit Command S or Control S out of habit, and it's asking me to save. I'll stop that for a minute until I finish what I was saying. Basically, what you see here is phase. You can hear, additions and reductions primarily as the phases line up differently with one another. But you need to have them basically juxtaposed with one another. And so you hear that. Now, it's not really all that smooth. You hear it stuttering a lot. That's because phase is a number inlet, and it operates at the control rate. So unfortunately, when you're trying to feed numbers in, it does skip. And in the digital world, you hear the snap or an artifact sound. And unfortunately, phase is like that. You can't put an audio signal into it, so you get that. But there's ways around that in creating phasing. But since this is more about wave shaping, I'm going to go on from here, save this sine example, and then move on to the other waveforms. But at least here you can kind of see some things about the sine wave as well as phase. Phase does play a part in wave shaping because you can use phase and using different waveforms in different phases to bend and make the shape of the resulting waveform more malleable by how you line these up. And so that is part of wave shaping as well. But now we're going to make just pure triangle, sawtooth, and square waves. Of course, we'll also see about the pulse waves, since square waves and pulse waves are in the same family. But let me save this first. Permit me to browse my computer a bit. I keep my PD stuff in here. Alrighty, let's find it. Dope. Projects, learning, synthesis with pure data, lesson 3. Okay, this is sine and phasing. Alrighty, that's saved. Now I'm going to save it to a new file name so I can change things and not ruin my sine example. We're going to now make a sawtooth. And we're going to do this in eliminating. Yeah, for this example, I'm not going to need all the tables. So I'm going to delete one here. I'm going to keep a result and then one that is the actual shape of the waveform. Okay. And so I'll delete the middle tab right here. Actually, I'm going to delete all this stuff here. Yeah, because this is not about phase. But I'm going to leave these tab rights to the side because I might need them. You can always make new ones. What the heck, get rid of them. Alright, so now, this is still something that would make, if I get rid of the second oscillator, just a straight up sine wave. We got the 0.5 in there. Let's get rid of that. And the plus. Okay, and the 0.2 at the bottom just to keep it from banging out the speakers. Alrighty. Here we go. This would just make us a nice, well, cosine wave. I think the last phase for this object was 0. Yeah, we can see it up there. Alright, so now what we're going to do is we're going to make a sawtooth. Well, you can't do that with oscillator tilde. Instead, you use an object called phasor. Although it doesn't really make a sawtooth wave per se, it makes a signal that's similar and that you can shape into a sawtooth rather easily. If you leave it on its own, it does sound kind of sawtoothy, but we're going to make it bigger and better. So let's do this. Let's hook it up. Phasor. It does have phase controls too, but we're not going to use it. But let me show you what phasor makes. And actually, I shouldn't have deleted all that stuff because I am going to make it again. I want to take a snapshot of it. Oh boy, here we go. This is where your shortcuts come in handy. Delay 10, we need back again. Let's make a message box here. PD DSP 0. The reason why I use the PD DSP 0 message to turn DSP off is when it's running, you could click this again to reset, and it resets everything from the beginning, because when you turn DSP off and then turn it on, your oscillator and phasor objects will start right from the beginning again. The beginning of their cycles, especially if you send them phase signals that do the same. And so we're going to have it once again turning DSP off and then on. There we go. We're making the same structure as before, so we can get a snapshot at the beginning. And message 69. This I'm also doing so that when I save the patch and close it up and you guys download it, it'll be using the same values because your sliders all go to 0 when the patch gets opened again and all that stuff. So we're going to send the A440 to it again. And that should be good for now. We need a tab right down here. And I'm going to change that to saw. Or actually, no. Let's call it phasor. It's not really a sawtooth wave per se. It's close. But anyway, we have to bang it, and we have to have signal going into it. Alrighty. Alrighty. Need to change the name of the table to correspond with the tab right object. I called it phasor. Okay, let's see here. Let's hit it. Uh-oh, something not right. A lot of times what you have to do when you type the table name into tab right first and then into the table, doesn't always work. It's good to type the table name into tab right second after there's already a table by that name. think that's what our problem was there. No! Let me make sure their names are the same. Phasor, P-H-A-S-O-R. And over here, P-H-A-S-O-R. This is receiving a bang end signal. That is not nice. It's not doing what I'm asking it to do. Let me test something. Let me hook phasor up to... We're not getting anything. DSP 0. Look at this. PDS. DSP 1. That doesn't turn DSP on. There you go. Syntax errors will get you every time. Alright. Gonna turn it off. But as you see, what phasor does is it makes a ramp from 0 to 1. Now that's close to a sawtooth shape, but it's not exactly a sawtooth shape. What we need to do to make it a sawtooth shape, and that's where this table is going to come in, we're going to make this sawtooth. So you can see how the ramp gets changed into a sawtooth. Let's call it saw. Okay, and we'll have a second tab right down here. Hold on, I made the object and put it over here. Alright, tab right tilde, saw. And now, let's hook this up to delay 10. So this gets the bang again to right, but after we do some math. Now, you can ignore the sine wave, that'll disappear. But in order to make this into a sawtooth, first of all, the sawtooth waveform really goes from 1 down to -1. So it goes from corner to corner in our table. If we want to get it going the right direction, we got to invert this. This is going 0 to 1. Well, if we multiply it by -1, we can make it go from 0 down to -1. That at least gets it going the right direction. So let's do that. Star tilde, -1. There we go. And now we're going to start hooking it up here to see the result. Although I don't have the DAC hooked up because we don't need to hear it. We just want to see it. So let's do that. There we go. Well, as you see, it's a little bit out of phase. I'm not sending phase to it. How about we do that? Let's put in a message with a 0 in it. And that way, when it starts up, it'll be in phase. It looks like just turning DSP off and then on again doesn't quite do it. You also got to send the phase as soon as you turn it back on. There we go. In fact, probably you don't even need to turn DSP off and on. You could probably just send phase. As long as all this stuff comes at once, you're good. But now we got it going the right direction. We got it going 0 down to -1. But we need to get it up further. So this is what we're going to do. Basically, we need to double its thickness so it's going the full height of the table. And that can be done by multiplying it by 2. Star tilde. There'll be one step after this, but star tilde 2 will at least get it the right height. Look this up to tab right here now. And let's bang it. Okay, now it's shooting out the bottom of the table because, first of all, we changed its range from 0 to 1 by multiplying it by -1. Basically, all the numbers in between, all the numbers other than 0, basically become negative numbers, so it went from 0 down to -1. Then we multiplied it by 2, and it made it go from 0 down to -2, doubling every number in between. So now to bring it up, if we add 1 to it, everything will be one value higher. And so then we should be starting at 1, going down to -1. Basically, we're shaping with math. It's in the digital world, since it's all numbers, that's what you do. There we go. Now we have a sawtooth. The main difference in sound between this and this actually is just going to be this will sound louder because now it has a full amplitude. Kill that. But, you know, I'm still attenuating it by multiplying it by 0.2. If I wasn't, we'd be hurting. So anyway, there we go. That's how you get a full-fledged sawtooth. Now, when you're using wave shapes like this, to make them sound better, there's other things you should do, but those are topics that come up later. I'm just showing you shaping and how the math works. So now I'm going to save this. That's our sawtooth. And what I'm going to do is save as again. And this time, we're going to make a square wave. I'm going to say square and pulse. Excuse me. And what we need for that is largely the same stuff here, but I'm going to cut out this math because it's going to change. I'm going to move this phasor object up. I should rename the table. End tab, right? So I'm going to call it now, let's just say pulse. Because basically a square wave is a pulse wave, but not all pulse waves are square waves. And we'll see that in a moment. But whatever we get in there will eventually be a pulse wave. Or do I want to leave phasor there? Actually, I'm going to do that. I'm sorry. I'm going to leave phasor there so you see where it starts from and where it goes to. I just renamed that afterwards. Let's make sure it still works. Yep. This table updated nothing. And, ooh. Hold on here. Oh, there we go. Now we're in phase. Alright, so now this is going to become pulse. Hold on. Let me rename it in the table first. Pulse. And then here in tab right next. Pulse. There we go. Now we have nothing hooked up here yet. Because basically, 0 to 1 of phasor is not a pulse wave. In order to make it a pulse wave, we run it through an object called expr, E-X-P-R, tilde. Now, what expr does is it's a mathematical expression object. And when you feed signal into it as a tilde object, it lets you put an expression afterwards that kind of allows you to run some math on that signal. And the math that we want to run on it for this object requires a little bit of naming. First of all, our signal coming through needs to be signified. And it's going to be signified with $V1, meaning vertex 1. And basically that means the signal coming in, the first inlet. And then for this type of expression, you can have other vertices afterwards. But what we're going to do is make a less than sign, and then $V2. And I'll explain what this means in a minute. Oh, I typed something wrong. Well, expr has an X in it. There we go. Ooh. Oh. Something isn't right here. EX, not SPR, EXPR. There we go. So, expr $V1 less than $V2. And then I'm going to hook this up, and we're going to see in a moment what happens. Now the $V2 that I put in is creates this second inlet on top, the right inlet. And for vertex 2, we need another signal coming in. It could be an audio rate signal, but it can also be a number. We'll accept that as well. So I'm going to make a message box here, and I'm going to send it the number 0.5. And you'll see what that creates in a moment. There we go. Hook that up. Now I'm going to have that hooked up to our bang tree here. Oops, delay. Oh, look at this. No wonder the phase was weird before. This is supposed to be hooked up after delay. So it comes at the same time as the others. I missed. Hook it up. And then let's hook up delay to our 0.5 as well. And then I'm going to hit the bang up here. It doesn't happen. Well, phaser's the same. What would change is pulse, and I never hooked it up to tab right. So coming out of X per tilde, we're going to hook that up into tab right pulse. And now you see what we get is a square wave. Its top line here, its crest, is right in line with the 1, so we see that, and then it comes down to 0, and then its trough here is going along 0. And so basically, what this expression means is vertex 1, the signal coming in, less than vertex 2, and vertex 2, the value 0.5 is coming in. What's happening is the 0 to 1 range, as it's coming through, anything less than 0.5 becomes 0. Anything above 0.5 becomes 1. And so that's what you get here as a result. Actually, I think it's the opposite. Anything less than 0 is becoming 1, and everything above, anything less than 0.5 becomes 1, anything above it is becoming 0. Actually, we can invert that easily by changing the less than sign to a greater than sign right here. And then we'll see the opposite occur. We'll see this crest and trough switch. There we go. Now everything below 0.5 becomes 0, and everything above it becomes 1. Now, that's when you use 0.5. This is the way you can change your pulse wave. This is a square wave shape here, although technically, if we want to do it right, what we should do is the math that we did with the Sawtooth before, where we basically want to multiply this and, well, subtract it first. Let's subtract 1 from it, move it down here, then multiply it by 2, and it should be all right. Or we could do it in inverse order. Let's make it a full square wave here. Let's do multiply star tilde, try again, star tilde, yeah, not exclamation point, 2, and you'll see what that'll do. That'll actually explode it out of the table, but it'll be the right width. Sorry, trying to hook this cable up here. There we go, but it's popping out. So we need to subtract 1 from it to bring it down within range. That's minus tilde. Come on, type it right. Crafty's getting pissed. Minus tilde 1. Okay, and so we hook that up and bring this over here, and then we're good to go. Now you see just the line going down the center there. But that's our full amplitude square wave now. Now, what I was going to do, first of all, if you want to hear it, Let's hook it up. That's enough of that. Alright, let's disconnect that. Let's just stay with the shape. Now, what I want to do is show you how in this expression you can basically vary your pulse wave and do what's called pulse width modulation. Now, the way we can do that is let's get rid of the message box here. We're going to put in another slider like we did with phase before. Command-Shift-H. Hook it up to the vertex 2 inlet. Go to its properties though and change it 0 to 1 because that's the range we need for this. Now, what I want to do is make this a moving table so we can see the pulse wave change, because we're going to see its width change over time. And so we're simply just going to put a toggle in, hook it up, turn Metro on. Okay, right now since DSP is off, it's not moving, but we could turn DSP on. And we didn't update the value in vertex 2 yet. We have to move the slider to do that. And actually, I just realized the slider, instead of being 0 to 1, should be, I'll make it 0.001 to 0.999. Basically, we don't want to get all the way to 1 or all the way to 0, just close to them. Because as you see, as I move it, the crests get wider as I go to the left. So you see this little dip in between, that's the trough being thin now. And as I go to the right, the crests get narrower. And there you see the pulses, basically is what you would say. The pulses are narrower now. Now we can hear this, see what it sounds like. Hook it up to both sides. Turn it off. Basically, what we would want to do, as I said before, there's some other things you would want to do at this state to make the sound less dirty. It sounds a little raucous right now, and there's some things you can do to fix that. We're not going to get into that just yet, because right now we're just doing wave shaping. I don't want to make the lesson cover too much stuff. But it also sounds a little bit dirty as we're moving this, because this signal's not going in at the audio rate. And it should for it to sound smoother, otherwise you'll hear pops and stuff. Now it'll still sound a little dirty and raucous, but we can make this transition smoother here by doing what we've done, I believe, already. And that's why we're going to make a message that goes into line tilde. And what line tilde does, since it's a tilde object, it operates at the audio rate, the sampling rate, and it sends things in the form of a line in samples. So it sounds smooth as it goes from one thing to another. And what we need to send it is a double message that sends the number coming out of the slider. So we're going to make a message by using the pack object. So we're going to pack the number coming out of the slider, which we represent with an F, and then we're going to send along with it the number 50, which means 50 milliseconds, meaning the line is going to be 50 milliseconds long, although it works out all the sample values in between that space so that it sounds smooth. Look, pack up to here, and it's pack F50, and you hook the slider up to the left inlet. If you hook it up to the right one, it would replace the 50 with a number from here, but we don't want that. We want it to be 50 milliseconds. And so let's turn it on now and hear it. Oh, hold on here. at the edges. And probably what I could do to do that is change the numbers. Basically, it's flattening it out too much to where the pulse disappears. Let's just make it 0.9 and 0.1. So that way, there's always going to be a pulse shape there in the table. As you see now, it's gone. Yeah. Alright, so that's the sound of pulse width modulation. It's a cool effect that you can add to things. And, well, you can add to pulse waves, and it's a part of synthesis commonly used. And it can be used in multiple ways, and we'll be exploring more of it later. Right now, that's our pulse waves and our square wave. And if you want the square wave, you just need to have this in the middle. In fact, just to set this up for when people open this, I'm going to bang this message through 0.5. Alrighty. Put that into the slider. Getting pretty messy. Crafty doesn't like it. But I'm also going to put a load bang on the toggle here. I think I'll add one to one of the previous patches I made. That way the toggle's on and we have a moving picture from the start. Basically, I want all our values to be sent that are necessary. You will have to hit the bang at the top to start everything, though. Alright. And there you go. So that's our square wave example. Now I'm going to save as... Well, I already did square and pulse. You know what I'm going to do? I'm actually going to close this now. Let's close this window. And I'm going to open up our Sawtooth again. What? Hold on here. I think I can do it right from here. Aren't I there? I'm in a different folder completely. What the heck? Okay. No, let's get out of the way. Let's go here. Here's our folders. Alright, Sawtooth. And I could close the old PD window. Missed it, so anyway, I'll leave it open just to be safe. Alright, so now we have our Sawtooth. And I'm going to save this immediately. Save as to a new name. This is going to be our triangle wave. Okay, I'm going back to the Sawtooth because this has things more close to what we're eventually going to make. First of all, I'm going to rename this. The result table, which is named Saw right now, is now going to become triangle. Because that's what we're going to put in it. And we're going to rename the tab right object here, the table name, to triangle. Good. Now, let's see. I'm going to take out this math here. Alright. There we go. Okay. So let's look at our top table here. This is what phasor gives us to begin with. Now, triangle wave is supposed to go up in a triangle shape, an equilateral triangle shape. Now, we could kind of get there by using phasor, but we need to alter it a little bit. For example, if we were to take this end of it, then make it start going back down again, that's the beginning of our triangle shape. Now, since phasor goes from 0 to 1, we need to kind of do this in parts. So I'll leave phasor hooked up here. And I'm going to make a second table because we're going to look at the parts that we're going to make. Let's duplicate phasor. And we're going to call this one, rename it because we can't have it the same name. I'm going to call it phasor I. Basically, we're going to invert phasor. So we'll need to make a new tab right just for that. But right now what we're going to do, we're going to have a second phasor here. And now we need to make this phasor go the opposite direction. One way we can do that is like we did before, multiplying it by -1 first. Star tilde, -1. That'll get it going the right direction. I'm going to make a tab right so you can see each step of the way. I'm going to hook this 0 up to this one as well. Okay. And I'm going to make a tab right just for this phasor on the right. Tab right tilde phasor I, which will be the middle table there. That'll be the display of this one. And I'm going to hook the delay object up to this tab right. Alright, let's hit it. What happened there? Oh, phasor's not receiving any frequency values. Gotta hook that up too. There we go. There, now it's going the right direction. But we want to move it up because we basically want it to be the second half of this. Okay, so we need to move it up by adding 1 to it. Move this up here. Plus tilde 1. Now it'll be going from 1 down to 0. It'll be where we want it to be. Alrighty. Let's hit it again. Okay, there we go. Now, if we were to kind of superimpose these things on each other, well, you can't really. It would look like an X, and since this flows over time, that doesn't happen. But what we'd like to do is this one, we want to keep the first half, and then flatten out the second half. And then on this one, we want to flatten out the first half and keep the second half. And then we can add them together. So the way we're going to do that is we're going to put this through an object called clip. And what clip does is it sets a range, clip tilde. It sets a range for your values that are flowing through it. Now for the one here on the right that I'm setting up, we want it to clip off at 0.5 and 0. So its range will be bottom 0 and its top 0.5. So anything above it gets flattened out. Now let's hook it up over here and you'll see the result. There we go. Now if we do the same thing to this, basically let's duplicate it. Move this over here. Then we hook it up to the top one. So we'll delete this patch here. So yes, the first table now is going to receive this clip. Getting messy, Crafty doesn't like it. Okay. No sir, don't like it. So let's move that down there. Okay, we're still on screen, good. Hit the bang up here, and so now we see we got ourselves two ends of it. Now what we want to do is add them together. And that's a plus tilde object, and you just hook one and the other into either end. Then we'll get our triangle shape. There we go. You see, it's kind of like a flattened out triangle, mostly because it's going from, in this case, Oh, it looks like we're going from 0.5 up to 1, back down to 0.5. The way these things add together, that's how they add up. Basically, we're adding, here this is flattening out at 0.5, and we're adding to it these values here. So it's shifting it up a bit. And so it's like from 1 down to 0.5. Same thing over here. So that's why we're getting from 0.5 up to 1. Now, if we want to expand that 0.5 up to 1, that we need to multiply by 4. That'll get it the full height that we need it. Alrighty. Hit it over here. Now it's the full height, but it's crashing up into the table above, because now its range is way off. We multiplied it by 4. It was going from 0.5 up to 1. So you multiply both of those times 4. It's going from 2 up to 4 now. So what we need to do is subtract from it. We need to bring that 2 down to -1. So we subtract 3 from it. And then that 4 will be subtracted down to 1. So subtract tilde 3. Okay. Let's delete this. Now hook this up over here. And let's bang out a result. Boom. We have our triangle wave. So anyway, if you want to hear it, we can hear it. Nice and smooth, calm and reassuring. I like triangle waves. Alright, there we go. That one sounds nice and cool on its own, and I'll give you a hint why. The other ones sound a little raucous because there are actually points where things are going from like 0 up to 1, or -1 up to 1 in the square wave. Same thing with the Sawtooth. It's ramping down like this, and it's jumping from -1 to 1. Here, the triangle wave starts and ends, begins and ends on the same value. So for the others, to smooth them out, you would really need to have them begin and end on similar values, putting a little extra line segment in there to smooth them out. And that would make them sound less raucous. But in any case, this is a nice sounding triangle wave. So we got that going. But anyway, that smoothing out and making the wave shaping waveforms sound a little bit better, that's going to be coming up, because the next step will be to make an oscillator module. We're going to want to start building components now. Now that we've demonstrated some concepts, it's good to look at how to build some components like one would use in analog synthesis. And so we're going to build an oscillator component, and then we'll get into dealing with control oscillators so that we can use oscillators to control signal and shape it as well. And that'll bring up FM and AM. And then we'll get into some filtering. We'll have all sorts of beautiful things coming up. But right now, you can see how to make basic wave shapes using the wave shaping technique. The wavetable technique using the sine sum makes not quite, exact wave shapes. In this case, you can get exact ones, but as you heard with the Sawtooth and stuff, you need to kind of like fudge them a bit to make them sound, pleasant. So we'll be getting into that next, because next we'll be making some modules that you'll want to keep and use. This was all theory at this point, but we're going to get into some useful modules next. Alright, so I hope you enjoyed our tutorial here on wave shaping. I'm going to go back to my web page and zoom out here. Remember, you'll find this example on my webpage here. You'll see lesson 3 appear in the list here above lesson 2, the video, and the zip file here. If you found the video on YouTube, you can go and find the zip file here. And that's basically it for now. Hope you enjoyed it. Don't forget, smack that like button. Give me some love. Alright, folks. Ciao for now. Okay, so I hope you enjoyed this lesson on wave shaping. As usual, if you found this video helpful, then please do leave a comment in the comment box or subscribe to my channel to be notified of future episodes. Also, you could like it. Just hit that like button. Any support would be very appreciated. And now we're going to once again go to Crafty's words of wisdom, because he has something he would like to share with you through me as his interpreter. Bienvenido al Hotel California. Cualquier tiempo en el año puedes conseguirlo aquí. Hay mucho espacio en el Hotel California. Tan lindo este sitio. Tan linda esta cara. Okay? Javelo, Chewbacca. Javelo.